In 2017, archaeologists working in the remote limestone caves of Sulawesi, Indonesia, announced a discovery that would fundamentally challenge our understanding of early human creativity. Using advanced uranium-thorium dating techniques, researchers from Griffith University and Indonesia's National Research Center for Archaeology determined that hand stencils in the Layang Bulu Sipong 4 cave were at least 39,900 years old. However, subsequent analysis published in Nature in 2021 by Dr. Maxime Aubert and colleagues pushed this date even further back to approximately 51,200 years ago for some of the oldest hand stencils in the region. More recent studies have identified mineral deposits over handprints, suggesting possible ages extending beyond 67,000 years, though these extreme dates remain subject to ongoing verification. These handprints weren't simply ancient, they represented some of the earliest known examples of symbolic human expression anywhere on Earth. For decades, the prevailing narrative suggested that sophisticated art emerged exclusively in Europe, with France's Chauvet Cave often cited as the birthplace of human creativity. The Sulawesi discoveries shattered this Eurocentric model, revealing that our ancestors across Southeast Asia were creating complex visual culture at roughly the same time, or possibly even earlier. The discovery site itself is challenging to access. The karst cave systems of Sulawesi's Maros-Pangkep region require navigating steep limestone cliffs, dense tropical vegetation, and narrow passages. Yet it's precisely this remoteness that helped preserve these ancient artworks for tens of thousands of years, protected from the weathering and human interference that have destroyed countless other prehistoric sites. If you're fascinated by how archaeology continues to reshape our understanding of human origins, please like this video, subscribe to our channel, and share it with anyone interested in our ancient past. Your support helps us bring more educational content like this to viewers worldwide. Understanding how researchers determined these handprints' extraordinary age requires examining the sophisticated dating methods that make such precision possible. Unlike organic materials, such as charcoal or bone, which can be dated using radiocarbon methods, mineral-based cave art requires different approaches. The primary technique used for the Sulawesi handprints is uranium-thorium dating, also called UT dating or uranium series dating. This method analyzes the mineral deposits, specifically calcium carbonate formations called cave popcorn or coralloid speleothems, that formed over the hand stencils after they were created. When groundwater seeps through limestone, it dissolves uranium but not thorium. As this water deposits calcium carbonate on cave walls, it incorporates trace amounts of uranium. Over time, the uranium-238 naturally decays into thorium-230 at a known constant rate, with a half-life of approximately 75,000 years. By measuring the ratio of thorium-230 to uranium-238 in these mineral deposits, researchers can calculate when the calcium carbonate formed. Critically, this provides a minimum age for the art beneath it. The handprint must be at least as old as the mineral layer covering it, and possibly older. Dr. Maxime Aubert, a geochronologist at Griffith University who led much of this research, has emphasized both the power and limitations of this technique. In interviews and publications, he notes that UT dating can only date the mineral formations, not the art itself. If mineral deposits formed long after the art was created, the true age could be significantly greater. Conversely, if minerals began forming almost immediately, the dates would be very close to the art's actual age. The research teams collect tiny samples, often just milligrams, of the mineral crust using dental tools, ensuring minimal damage to the artwork. These samples undergo rigorous laboratory analysis, including laser ablation and mass spectrometry, to measure isotope ratios with extreme precision. Multiple samples from different areas of the same artwork help establish reliability and identify any contamination. The Sulawesi handprints weren't painted onto cave walls. They were created using a technique called negative hand stenciling. To create these images, individuals placed their hands flat against the rock's surface and blew or sprayed pigment around them, likely using their mouths or hollow tubes made from bone or bamboo. When the hand was removed, its silhouette remained as a lighter area against the darker pigmented background. The pigment used was primarily red ochre, an iron oxide mineral that early humans across the globe valued for its vibrant color and availability. Ochre deposits are found throughout Sulawesi, and evidence from archaeological excavations shows that humans processed and used ochre in the region for at least 40,000 years. The ochre was likely ground into powder, then mixed with water, animal fat, or plant-based binders to create a sprayable mixture. Analysis of the handprints reveals intriguing details about the individuals who created them. Many appear to be adult hands, though some smaller prints suggest adolescents or possibly children may have participated in this artistic practice. The positioning varies. Some hands are fully splayed, others show missing digits, which researchers debate could indicate either ritual amputation, documented in some later cultures, frostbite or injury, or simply fingers deliberately bent during the stenciling process. Unlike simple random placement, many handprint panels show deliberate composition. Some are clustered in groups, others are isolated, and certain panels show hands overlapping in ways that suggest repeated visits to the same surface over time, possibly centuries or even millennia apart. This layering provides another dating challenge and opportunity. By dating different mineral layers between overlapping handprints, researchers can sometimes establish relative chronologies showing that cave art production continued for extended periods. The question of meaning remains speculative. Were these territorial markers, coming-of-age rituals, artistic expression, spiritual practice? Without written records or direct cultural continuity, archaeologists must remain cautious. Dr. Adam Brum of Griffith University, a key researcher on these sites, has stated in publications that while we can document what was done, we must be humble about claiming to understand why it was done. Sulawesi, Indonesia's 11th largest island, occupies a unique position in understanding human migration and cultural development. Located in Wallisia, the biogeographic zone between continental Asia and Australia, Sulawesi was never connected to either landmass by land bridges, even during Ice Age periods when sea levels dropped dramatically. This means any humans reaching Sulawesi during the Pleistocene epoch required seafaring capabilities. The Maros-Pangkep karst region, where the handprints were discovered, is one of the world's most extensive tropical karst landscapes. Characterized by towering limestone formations sculpted over millions of years by water erosion, this region contains thousands of caves and rock shelters. During the late Pleistocene, when these handprints were created, the climate was cooler and drier than today, with lower sea levels exposing more coastal plains. However, the region remained tropical, supporting diverse forests and the animal species that early humans hunted. Archaeological evidence from sites across Sulawesi shows that modern humans, Homo sapiens, reached the island at least 50,000 years ago and possibly earlier. They encountered an ecosystem dramatically different from mainland Asia, including dwarf elephants called stegodon, giant rats, and unique marsupials. Excavations at sites like Layang Burung II and Layang Tedonggi have recovered stone tools, animal bones showing butchery marks, and evidence of fire use, painting a picture of resourceful communities adapting to island conditions. The geology of the karst caves themselves played a crucial role in art preservation. Limestone's chemical properties allowed the formation of protective mineral crusts that sealed the handprints from weathering. The cave's relatively stable temperature and humidity, combined with limited direct water flow in certain chambers, created ideal preservation conditions. Many decorated caves show evidence of repeated human occupation over millennia, with stratified deposits containing tools, food remains, and other cultural materials. Understanding this environmental context is essential. These weren't isolated artists working in a cultural vacuum. They were members of sophisticated communities capable of ocean crossing, tool manufacture, hunting strategies, and symbolic thought. The handprints are just one element of a much larger behavioral repertoire. For over a century, European cave art dominated discussions of early human creativity. Sites like Lascaux in France, Altamira in Spain, and particularly Chauvet Cave, with spectacular animal paintings dated to approximately 36,000 years ago, were considered the pinnacle of Paleolithic artistic achievement. This created an implicit narrative that modern human cognitive abilities, including symbolic thinking and artistic expression, either originated in Europe or reached their fullest expression there. The Sulawesi discoveries fundamentally disrupted this framework. The hand stencils in Indonesia are comparable in age to, or potentially older than, Europe's earliest known cave art. More significantly, they demonstrate that geographically separated populations were independently developing similar artistic practices at roughly the same time. This suggests that the capacity and inclination for creating symbolic visual culture was likely a shared heritage of modern humans before populations dispersed from Africa, rather than an innovation that emerged in one region and then spread. Stylistically, there are both similarities and differences. Hand stencils appear in European caves as well, particularly in sites like El Castillo in Spain, dated to at least 40,800 years ago, and numerous French caves. The technique, negative stenciling using blown pigment, is essentially identical across continents. This could indicate either independent invention of the same logical technique or possibly a shared cultural practice from an earlier common population. However, the broader artistic contexts differ. European cave art is famous for elaborate naturalistic animal depictions, horses, bison, lions, rhinoceros, rendered with sophisticated understanding of form, movement, and shading. While Sulawesi also contains figurative art, including a 45,500-year-old pig painting discovered at Leang Tedunge, announced in 2021 as the oldest known figurative artwork, the relative proportions of hand stencils versus animal depictions differ between regions. Dr. Paul Pettit of Durham University, who studied Paleolithic art across multiple continents, has argued in academic publications that these parallels suggest symbolic behavior was a fundamental capacity of Homo sapiens wherever populations migrated, rather than a sporadic or regional innovation. The art doesn't represent European superiority or Asian imitation. It reflects universal human cognitive abilities expressed through locally available materials and culturally specific motivations. While the Sulawesi handprints have revolutionized understanding of early human art, significant questions remain unresolved and scholarly debates continue across multiple dimensions. One major area of uncertainty concerns the maximum possible age of the earliest handprints. The dates of 39,900 to 51,200 years are well established for specific stencils based on uranium-thorium dating of overlying mineral deposits. However, some researchers have noted that if substantial time elapsed between art creation and mineral formation, the actual ages could be considerably greater. Suggestions that some art might exceed 65,000 years remain controversial and require further validation through additional sampling and dating of mineral layers both above and below the pigments. The identity of the artists also generates discussion. Were they direct ancestors of modern indigenous Sulawesi populations or earlier populations subsequently replaced or absorbed? Genetic studies of contemporary Indonesians show complex ancestry involving multiple migration waves, and ancient DNA from Pleistocene-era remains in the region is limited. The relationship between these early artists and later populations remains unclear. Methodological debates also persist. Some researchers question whether all dated mineral formations began accumulating immediately after art creation, or whether significant gaps might exist. Dr. Alistair Pike from the University of Southampton, who helped pioneer uranium-thorium dating applications for cave art, has emphasized in publications the importance of understanding site-specific mineral formation rates and contamination possibilities. Different research teams sometimes produce varying dates for the same sites, highlighting the technical challenges involved. The interpretation of artistic motivation and meaning generates perhaps the most diverse scholarly perspectives. Some researchers emphasize ritualistic or spiritual dimensions. Others focus on social identity and territorial marking, and still others see primarily aesthetic or communicative functions. Without ethnographic parallels or direct cultural continuity, these interpretations remain speculative, though carefully reasoned based on archaeological context and cross-cultural anthropological knowledge. Recent technological advances promise new insights. High-resolution 3D scanning allows non-destructive recording of entire cave art panels, preserving them digitally even as originals face weathering threats. Portable X-ray fluorescence analysis can identify pigment composition without sampling, and improved dating techniques may eventually allow direct dating of pigments rather than only the mineral crusts covering them. The Indonesian government and international research collaborations have increased site documentation and protection efforts, though challenges remain. Tourism pressure, limestone quarrying, and climate change all pose threats to these irreplaceable cultural heritage sites. Balancing scientific access, local community interests, and preservation needs requires ongoing negotiation and careful management. The 67,800-year-old question posed by the Sulawesi handprints isn't ultimately about dates or techniques. It's about what these ancient images reveal about the nature of human consciousness and culture. When someone pressed their hand against limestone in a Sulawesi cave tens of thousands of years ago and sprayed pigment around it, they were engaging in an act of profound significance. They were making a permanent mark, declaring, "I was here." They were transforming raw materials into symbolic communication. They were participating in a cultural practice that likely had meaning shared among their community. They were, in short, doing something distinctly human. Symbolic thought, the ability to let one thing represent another, to create meaning beyond immediate physical reality, appears to be among the defining characteristics of our species. Language is symbolic. Sounds or written marks represent objects, actions, and concepts. Art is symbolic. Pigments on stone represent hands, animals, or abstract ideas. Both require cognitive abilities that, while possibly present in rudimentary forms in other species, reach unique expression in humans. The geographic and temporal distribution of early art suggests these abilities weren't learned behaviors that spread gradually across populations, but rather intrinsic capabilities that different Homo sapiens groups expressed independently when circumstances and resources allowed. Whether in France, Spain, Indonesia, or South Africa, which has its own ancient rock art traditions, early humans created visual culture. This has implications for how we understand our species' origins. The traditional human revolution model suggested that behavioral modernity, including art, complex tools, and symbolic culture, emerged suddenly in Europe around 40,000 years ago. Evidence from Sulawesi, along with African sites showing early symbolic behavior, has largely displaced this model. Current consensus, as reflected in publications by researchers like Dr. Chris Stringer of the Natural History Museum, London, suggests that behavioral modernity developed gradually in Africa before Homo sapiens dispersed globally, with different components appearing at different times and places. The handprints also remind us of art's endurance and fragility. These images survived nearly 70,000 years of climate changes, volcanic eruptions, sea level fluctuations, and human history. Yet they face unprecedented threats from modern industrial activity, climate change, and even well-intentioned but poorly managed tourism. Organizations like UNESCO and ICOMOS work to balance preservation with access, recognizing these sites' importance to all humanity while respecting Indonesian sovereignty and local community connections. Perhaps most poignantly, the handprints create a direct connection across vast temporal distance. The hand that created that outline had the same basic anatomy as yours. The person attached to it experienced hunger, community, wonder, and the impulse to create something lasting. They succeeded. Their message has reached us, though we may never fully decode its meaning. That alone testifies to something remarkable about our shared human journey.